think I'll start you out with the challenge. When Keon and Dan come, we can start in on it too. So it should be pretty simple. Recall that we were talking about the three objects of Git. So this challenge has to do with that. So what are the three objects?
Branch, tree, and blob.
Tree is one of them.
Glob.
Blob is another one. Not branch. Remember, branch is just a pointer. It's a pointer to it.
No.
What was that, remote?
Shaw.
They're all of them are SHAs.
Okay.
They're all categorized as SHAs. That's how they're produced.
Tree.
So a branch points to this type of Git object, this type of SHA. Tree, blob, and it has your parent, it has your comment, it has your
Commit SHA?
Commit SHA, yes, thank you. Commit, tree, and blob. So if you go to your repo, and if you recall where your repo is stored on disk, right, what directory it's in, the challenge is to go into that directory and find the file storage that corresponds. Should I probably just better put this up on screen now that I'm saying it. Okay, so here it is. Let me make this a little more, oops. Get this out of the way. So find the file on disk in your .git directory that corresponds to the last blob SHA and the most recent commit. Blank stares are okay for a few seconds while you process that. So the command we used, this will help, is that git space cat-file space -p that shows the contents of a given SHA. So that will help in this exercise. So kind of work backward on this in this sentence from the very end toward the front. It's probably going to help you.
Cat file.
So where do you find your most recent commit? The SHA for your most recent commit. How do you surface that? ADOG will do it. Yeah. You can also use. There's other ways. You can use Git Rev Parse, which I haven't shown you yet, which kind of resolves whatever you feed it. Which could be master. What's master resolved down to? You could ask it for head. You could ask it for anything that means a commit, and it will tell you the SHA for that commit. Or you could just ADOG, yes. Or not, just ADOG. Yeah, there we go. So. Anybody got there yet? Anybody got there yet? Okay. That's what you do.
I kind of noticed this morning, so it's the same.
More and more like Windows.
Yeah, VS Code wasn't coming out, and then I kind of shut it down. So I restarted.
Yeah, it's starting to feel like that. When it now just restarts.
Is everybody able to see the content of the commit, the fields in the commit with the cat file command? So let's do that. If seeing that my commit is this, so try that. Let's see if I can. Unable to do that. Cat file dash P of the last commit.
Oh, okay. Do you want to see the content of the blob?
Well, you could do that, but I'm not really asking for the content. I'm just asking for where that file is that has the content, like down in the .git directory.
So if you do that object in first two folder, based on the first two characters of the file, and the rest of it.
Don't ask Ethan about movie plots because he'll just tell you. But yes. But you can't quite get there from here without another step. So there's no actual blobs in this cat file, right? So how do you see the blob? Where would that blob be in this data schema?
Blob is the grapes.
The blob is the grapes.
All of the branches of the grapes.
Right. And branches live on trees. So
Remember the commands.
Hey, Chris,
still get cat file. Yeah.
can you repost that repository? I've changed computers since we last saw you.
Oh, absolutely. Absolutely. So git -b. So yeah, this would be it right here. If you could see my screen, just
Yeah.
git clone that.
So when you the file from here,
So the last blob file that corresponds to the last blob.
David, do you want to mute yourself? Remote team, if you're, can you please mute?
Sorry, can you say that again?
yeah.
Can you mute yourself, David? You're knocking around a lot.
Oh, sorry. Yeah.
So yes, the tree would be here, right, on this commit that I just listed. Right, that's the tree that corresponds to the directory structure that Git would expand into my workspace if I checked out this commit, which I have since I'm right here on this this branch.
Mhm.
So there's the tree. No, that's not it. That's the same thing I was doing before. The tree is this. Copy paste. There's some blobs.
Yeah, so I got that.
So the last blob is going to be this guy. At least in my my repo. It may be different for you, that's fine, but just whatever that is. So
Sure. So it's where there's no more trees in your in your console view of directories, right? I'm what I'm saying.
yeah, no, yeah. So this, yeah, what we're basically just taking where we're at in our repo and kind of digging into the data structure that you know ends up creating the files in our repo on the disk.
Sure, well, in the-
And then we're sort of, yeah, and we're sort of going around and poking around in that, in its representation inside the Git repo to find out, you know, how it consists of commits and trees and blobs, and then we're going into the actual database, so to speak, the .git folder, and finding that file that corresponds to this blob here at the end of this tree list. So where would I CD after .git/objects if I'm looking for this guy right here?
Maybe the first two.
Yeah, 3.3. And then just ls and look for something that starts with 8F64. Okay, so there it is. Does that make sense to everyone? Now we can't look at it directly, recall, because it's, you know, it's a compressed format. But we can use git cat file to look at it, right? We can use, and of course, git cat file expects the actual SHA, not the file name, which is not going to have all the characters on it. It's going to be missing the front two. But there's the content.
That's what I'm reading right now.
What's that?
It's about
Yeah, it is. It really, truly is. All right, so everybody okay with that? It's not, again, not something you do every day or, you know, as part of your normal Git workflow, but it helps you, you know, helps kind of refresh the notion of what kind of SHAs you're working with and the Git data model.
I was looking at my last commit for the challenge we worked on after you left yesterday.
Okay.
Or, the day after we were here.
Okay.
And, I was not able to do what you had accomplished here. Going into that directory with the first two letters of the SHA.
Oh, the objects. Okay. Just now.
Just now, I wasn't able
Let
to
me take a quick.
So, don't you have to actually expand that with the object?
Expand out.
It doesn't, like we actually ran a command that actually extends out to create the object folder and spread it out and create that tree.
If you have cloned from like a remote, that remote might have done some compression. If you're just local, then you probably don't have to do any expansion. So let's see what your so you're in master. Okay, so you through. So you.
Do you want to see where I started, or you?
Yeah. So you.
That was.
Okay.
Here it is. So I started with this.
Should that heat or no?
The 511. Oh.
I
No,
know.
I should have started with the FFU.
No, well, it's fine. So it's fine. All right. So tab that. Okay, what did that say? Okay, so you want that. Here it is. Right there. Okay, so then your tree is 21C, 63. Okay, and you got that, and then you got CD0.
Oh.
So this is what you would look for. It's a CE.
Oh, I see. How do you learn?
Because it's just the first two characters of the shop. That's just what all SHAs, whether they're commit or tree or blob SHAs, that's just how it stores all the SHAs, all those types of SHAs that it had.
So why wouldn't I continue to explore the tree here? Why do I know that this is the blob that I want?
Well, it just says blob. I mean,
Oh, but there's these two also. Oh, you're saying the last blob from the first.
from the commit. So each commit has one tree that corresponds to that directory structure, right? And then from the tree, it builds out your directory structure, which may have more trees and blobs.
But I want the first blob from the first SHA. I don't want to go down this rabbit hole of trees. So.
Yeah, I wouldn't do that. Okay, you could, but I just wanted to have you go through that exercise to see to be refreshed in this whole data model.
Sorry for the confusion.
Oh, no worries, no worries. So stop me anytime, like if I'm typing something or saying something and just whisks right by, or or like, hey, how'd you do that? Because I like to learn things too, things that make my day more efficient. So go ahead.
Sorry, can you show the last command you sent to bring all that out?
To bring all that out. So yeah, that was just. So every time we say get cat file, we're looking at the content of whatever SHA we're passing it. And so the last thing we looked at was a blob SHA. So when you do that on a blob SHA, you look at the the actual content that you have considered to be source or text or whatever, whatever your actual code is. So because this is a blob, it's just pure content. There's no data fields per se. It's just the file contents of this file that you would be working with and versioning and committing to Git. All right. So any more questions on that front? So recall I said that I wanted to get you to the place where you could use Git to go back to where you were before things go south. So let's say I am, oops. So here I am in my directory, and we've done some work, and I actually, moved master around, and I added this branch, and it's not like it was. So how would I get back to just making it as if I had just cloned it without actually going back and blowing it away and just cloning it again? What do I need to do to restore it to its former pristine state? Well, I guess first of all, what would that look like? What should this graph look like, or this ADOG look like? What's wrong with it now that should be fixed?
The head master should be
okay.
The origin, or
Should be
in line, okay.
Origin down to where that's at right now should be show that it's behind or get backed up since that must
Okay. Yeah, that could be the case. I mean, we're not. I don't think we need to mess with this state so much. We could do that. That's just reflecting the reality of some remote state. So we don't need to really change origin master or origin head, I don't think. But yeah, definitely this head master. How do we get that back up in line with origin master?
Git reset -- hard.
Okay.
And then the first 4 of the SHA.
Okay, which I just lost. So what do I feed the reset?
DB62F.
Okay, okay. Or I could just do, since this will end up being the same SHA, right? I could just say that. Either way would work. And it says, nope, you can't do that because you're in the wrong directory. So let's try that now. Okay, let's see how that worked. Okay, all right, that's better. What if we don't need this branch up here? What do we do about that? Would there be any negative consequences to just deleting it, or no?
I don't think.
Depends on what you do in that branch, I guess.
How many votes yes? How many votes no? Votes yes.
Or negative consequences.
Negative consequences. No
Raising my
votes
hand.
here. Okay. One vote remote. How about no negative consequences? Okay, a lot of votes here.
I don't know why. I just
You don't know why, but okay. Piling on. All right. Time-honored tradition. So yeah. So if we take this off, it's not. There's no SHAs that are only on that branch. Does that make sense? I mean, this SHA is on, or this branch is on this SHA. It's probably more the better way to say it. But master is also on this SHA. So even if we take this pointer off, this one is still going to be here, and this is where we're kind of living as our current head. So yeah, we can do git branch -d for delete, and it should let me autocomplete. Yeah. Okay, let's see how that does. Okay. So I can't change to that branch anymore. I mean, if that's a negative consequence, then I guess that counts. But I can just recreate it. I haven't lost my place.
Is that a -n instead of Z, or what would it be?
To create it.
To create it again.
So here's a little nuance of Git that keeps biting me once in a while. You can do Git branch. Make a branch name, and then optionally you tell it where you want it to put the branch. You could put it anywhere. If you don't tell it, it'll just put it where you're at now.
You give it a shot.
Mm-hmm. Well, that's what this would evaluate to, right?
Oh, okay.
It would resolve to a SHA. But yes, you could give it anything that is a commit SHA.
That's cool.
So it is very cool. So if I could give it 3 things before head if I wanted to. Make a branch there. Right, so now it's down here, three commits before head. However, what branch am I on? Still on master. So you do, git branch, my new branch, let's start work. And then you start working without actually checking out to that branch. All your work still goes on master. So let's do that. Let's pretend that we just did that. So make a branch somewhere that's not head, because this happens surprisingly often. I'll show you what you can do instead. You probably know this already, but let's do this first. So make your branch, it's made, and edit some file with VI or code, make a change, save the file, status, here's the file, Git add the file, Git commit the file.
You just code, you open the, did you open the file?
Yeah, you can just say code space test.sh, I believe, and it will pop into your VS Code editor. And doing an A-dog. And oh, whoops, look at that. Here, like I was hoping, but now it's up here,
Look at that.
still on master.
Is it testing? Yeah. Okay.
Shoot.
Yeah. Shoot.
What do you do now?
Re-download the.
If you are new to Git, you may just blow away the repo and reclone it and try it again.
Yeah.
Because now you're out in the weeds, right? But knowing what we know now, we don't have to do that.
So what's our goal?
So we thought we were doing this on this branch,
Oh, okay.
right? But are we doing it on the branch? Yeah, it's you know, this Shaw's parent is clearly origin master, not do it again branch. So we've got this thing. This thing has the wrong parent. So there's quite a few ways we could fix it. Some of the ways we have the tools for from last class. Any suggestions about how we would fix this?
We want to take the commit that we just did and make it a part of the branch that we just made.
Exactly. We want to put it down here instead of, you know, up here off of this commit. We want to put it off of this commit, not off this commit.
We can't, if we do the hard reset that we just did, we would just move the head to that Shaw, right? But it wouldn't,
Right.
It wouldn't affect the comment of the commit that we
Yeah, it wouldn't move the commit anywhere. It would just move it would move us back. It would move us back to here, and this would just not have anything pointing to it at all. So we would lose it. We pretend we did a lot of work, right? So we don't really want to lose it. We want to move it. So
Can we put, can you, I don't remember.
so how is there anything we did Tuesday that lets you uncommit? Okay, it's the right track. So what happens? What happens if you do a soft reset?
It changes the first level.
Well, let me rephrase. Where do you want a soft reset to? Exactly.
To the branch. You just
The origin master.
Origin master. Okay, so we soft reset back to here, right? So how do we say that on the command line?
Git reset
Reset.
dash soft, and then the or head for origin master.
Okay, yeah, we could say origin master. We could also say the exact SHA if we remembered it. We could also say head caret, right? Because the commit that needs moving is pointing to that thing, so that would work.
we lost our.
So what happens now? What do we expect to see now if I do a git status?
Heads on master.
Heads on master. Anything else?
You're going to see your file staged.
Just the stage, but not.
Staged, right? What would we need to do if we wanted to see it as modified instead of staged?
You have to do a medium reset.
We could do this.
Mixed. Yeah, exactly. We could have done mixed, and that would put it further out. We don't really need to modify it again, though. So probably soft is the shortest path, if we're using Git Reset. So because we just needed to get it back, we changed the Git. We changed where we're pointing with master. What's that? Git Reset. Yeah. So we're kind of back where we were before we committed, aren't we? So what if we just go ahead and check out to that branch? Well, what happens? Oh, can't do that yet. Because we got changes.
What is GC?
Oh, that's just an alias. Yeah, Git checkout.
Git checkout.
Yeah. Let's just Git checkout. So how would we handle, oh, thank you for having my back.
Can you stage the changes again? Or
Stash.
stash, I mean.
Yeah, stash would do it. Just do Git stash. We didn't touch on that much, but yeah, that would work. And now, if we do a Git status, we're clean, which means we can now do a Git checkout. Okay, now what?
Switch to branch.
What state are we? So here we are here. We're on the right branch now, which is cool. What else? What do we need to do next?
Well, give this a shot or work a static.
Yeah,
Can we get full?
you can unstash, which is Git stash pop. So stash is a stack, so we can push and pop. Git stash is a Git stash push basically. So Git stash pop unstashes. Let's see how we're doing with. So yeah, so now our Git stash is gone. Our record is gone. Yeah, because we don't need that pointer anymore. But we've got what we want now in our workspace. Modified. It's interesting that it shows us modified and not staged, but whatever.
And now do your commit.
Okay. Yeah. So now we can Git add. If I do Git add dot, what does that do? Right. Handy but dangerous. So have you guys used Git ignore at all, by the way? Dot Git ignore? Okay, I'll cover that next. So yeah, status, we can search for by, so if I still have the command in my history, I can just reuse that command, do it again. Oh, actually that's the wrong command. That's the wrong dash, sorry. Have you used dash amend? So amend just redoes the exact same thing. It's kind of the equivalent of doing several of these commands we've been doing all in one go, and just ends up changing just the comment in this case. Sometimes you want to change the the author or the committer. So you could do something like something like that. So, but the actual everything else stays the same. So it's just a shortcut for kind of this Git reset, Git add, Git commit sequence that you could also do to accomplish the same thing. Okay, what's it look like? Okay, does that make sense? Is that what we wanted to do? This graph?
Added our new branch.
Erase that arrow just because it's right. Everybody remembers this is tonight, right? Okay, so what are we? So this is where we were. We went back down to here, and then we made a change and committed this thing with this comment, right? Is that Is that what we wanted to do?
I feel like the answer to that question is no.
Okay.
Yes.
Let's do. Let's check what we've actually done. We can do a git show to see what the changes. Like basically, git show does a diff of what your the commit that you're on with its previous commit. Is that what we changed? Or it's what I changed, I think, right? And we are on this other branch now, right? Because we're leaving this alone. Nothing is, this is up to date with origin master as it was. Master's over here, but we're not on it anymore, right? Because we checked out to here. So I think we're okay. I think we got it done. What should we have done instead to avoid all this roundabout, long way around? If we wanted to just develop on do it again branch, create it and go to it in one go. Is there?
How do you set the head to the branch? And then commit it?
Well,
You go to Git, check out my. Actually, you can make a chat. Allow you to check out and create it and go to it.
yeah. So minus b, some other branch. Okay, now it does a checkout and creates the branch. So yeah, that's what we really wanted to do. So, and of course, if you go GC, there, that doesn't, it's not quite enough. You have to tell it to create it if it's not there. So, all right. So let's do some more cool stuff. Let's see what, done that. Fixed branch. We talked about git stash. There's not that much to git stash. I think we've sort of used it in a way that introduces it. Unless anybody wants to talk more about it or feels like it's still mysterious, but it's basically just this stack that you can push changes onto if you get interrupted in your work. You're working on your stuff, you haven't committed yet, you suddenly need to go to another branch and fix something in production. So you do a git stash and then you git checkout to master or your development branch, make the fix, push it all up wherever it goes, and then you git checkout, git stash pop, and you're back where you were before. Continue on your way. Or you could do a checkpoint commit as well if you want.
Checkpoint commit is just committing every time.
Yeah, just commit it in, and say this. I'm coming back to this, with your comment.
Sure.
And then you could do a git reset once you get back there. That accomplishes basically the same thing.
Why would you get reset after the checkpoint?
Well, it's because it's kind of a partial, it's like work in progress. So maybe not everything is there that you want to actually commit because you got, the scenarios you get interrupted, but you don't want to lose everything you've done so far.
The commit saves, which
Yes.
and then you go to another branch completely.
Mm-hmm.
Commit something there and then come back to
Push it up. Yeah.
push it up.
Deliver it.
Okay. And then when you come back, you're resetting because you're just going from the new branch to the previous branch, right? Like we just did.
Yeah. So we go to do it again. Right. Here we are. Suppose what we committed here we're not quite done with.
Okay.
Right. We can just say git reset -- soft or mixed. Right. If depending on whether we want to just stage some more stuff, then we can just do soft because then we have so our git status now says here it is, and then we just add some more stuff to the commit, git add, and then we recommit it. Now it's done, right? Which is kind of the effective equivalent of a git stash and a git stash pop. So
Is there a way to add multiple files on Git Add?
Absolutely. Yeah, just give all their, you just say, you know, file, directory, you know, whatever directory. Yeah, just whatever R's you have on Git Add, it will add those. Or,
Okay.
recursively, by the way. So if you give it a directory name, it'll put everything in that directory into your index. Which reminds me, let's see if we have one of these. So git ignore is incredibly handy. So what git ignore does is say, there are some things in my repo that my source, you know, my IDE creates that I really don't want to commit. Some object files, you know, cache stuff, things that you know, it's going to blow out your repo possibly if you do commit it, or clutter it up, right? Maybe you've got an npm module directory, which are always huge. So you can just go into, you can make a git ignore file. I'm going to edit it here with VI, and you can just basically, this is everything that we should ignore, is what we're saying here. Ignore anything that starts with capybara and, you know, has anything after that and ends in HTML. Ignore the whole .rspec directory, right? Ignore anything that starts like the directory. Slash here means slash relative to your repo, not relative to the root of your file system in this case. So yeah, SQLite 3 databases, don't want those. You know, you'll find like all kinds of like you know, Vim swap files, you know, things that are just stuff you don't care about. So put it in there. There's a lot of vendor bundle. If you get into Ruby and Sinatra and Rails, all your gems, you know, by convention are stored under vendor bundle. You don't want to check those in. You know, Python environment stuff, you don't want to check that in. You check in the requirements.txt for your environment to create it, but you don't check in the environment itself, because it's going to be huge, and it won't work on other machines possibly anyway. So, and then you just commit it like if I were to put something in it, I just commit it like a norm, you know, just any other file. Right. Make a change. Shows up as modified. I do git add, git commit along with everything else. So very, very handy.
And what's the VI for?
All right. Any questions? VI?
Yeah, you put
that's-
VI in front of git ignore.
Oh, that's just my editor. That's my command line editor.
Oh, okay.
Yeah, it used to be VI in the 70s when Bill Joy wrote it, and now it's VIM. I'm not sure what Vim means, but it's better. But VI is cool. It's always been cool. All right, so Git Merge. How many people have done a Git Merge? Once. Done it once.
We have been practical.
Okay. Let's do a Git Merge because you're going to have to do it a lot, and it's going to be confusing when you do it. Your IDE may make it easier by highlighting differences, but I think it's worth going through on the command line just to see what's really going on. So let's get in a situation where we'll have to do a Git Merge. So if you haven't done this, go ahead and, you know, make a commit on another branch that we can then merge. So like, what did I change? We want to make a commit that's going to have a collision when we merge. So, okay, does that make sense? Git show. Is that what I changed? I think I'm confused. All right, let's do it so we're all doing the same thing. Oh, I think I did a Git Reset, didn't I? I'm just going to go to Reset Hard Master. No, I'm not. I'm going to do a Git. Yeah. Okay, I'm going to throw away the changes on my current branch by just resetting to the head that I'm on, which forces everything to be like head, basically. So now I can go back to master. So let's all git branch or git checkout -b branch to merge. How about that? This will take a little setup, but it'll be good practice, I think. So what we're going to do is make a new branch, make a change to a line in a file, come back to master, make the same change, well, make the different change to the same line, and then we'll try to merge the first change back in and see what happens. Okay? So we did the git checkout -b, and let's just open that test.sh again. I wonder if I've got code on my box. So I can do code test.sh if I want to. Maybe. Yeah, there it is. And I'll just add a change to the first line to make it easy. This is my change on a branch. Say that, something like that. Save. Go back to the command line, look at my status, modify just like I expect, git add it, git commit it. Okay, so now I have what I expect. Yes, I branched off of master to this branch to merge, and now I've got a commit that's only on branch to merge. So far, so good.
I tried the shortcut for git commit. Separate window with file.
So did you do your on this down?
Oh, it's probably what happened.
Yeah, it opened a separate window, and yeah, it's wanting you to put your comment in. Save it next. So you're on the right track. If you don't say -if, it will put you into an editor to wordsmith your comment.
So now I missed what happens after we.
So yeah, git add and git commit. We're all still on this other branch, and then I just used ADOG to check that everything looks good. Okay.
Branch to merge.
Mm-hmm.
New commit.
Yeah, we should have some change up here that is ahead of master because that's where we started from. But our head pointer is on branch to merge and not master. Okay, so let's go back to master. And we did test.sh, I believe. So let's do that again. Okay, and pops us into what looks like the same file, but it's back on master. Okay, here is the change I made on master. Okay. Save that. So still line 1. Go back here to our command line. Do status. Okay, it's modified. Add it. Commit it. Just git commit -m. Changing the first line of say on master, whatever you want to put there. Okay. Let's see how we did. Okay. Does your result look somewhat like that? What's that?
We have one from the earlier.
Okay. So like, if you want to get rid of something that's just in the way, like this distracts me. So what I'm going to do is just delete it forcefully. So you can do git branch -D. If you do lowercase t, here's what happens. It says you can't do it. But then you can force it. It didn't force it. So if you want to force it, you can do a D, and then it goes ahead. And then it just goes away. The commit is still there, recall, but the branch is not pointing to it, so it doesn't show up for you. So just sometimes comes in handy. This one we can do. Do we need a D for this one or not? Why not?
The file that references it is already committed, it's already part of it.
Right.
Or in the history chain.
Right. Yeah, if Git sees that, you know that it's already kind of, it's something else has this thing as a parent that you can trace it back to. In other words, it's already merged. Then it will say, yeah, that's fine. Go ahead. You're not losing anything. So we can do. Was it someone? No, it was. What was it called? Do it again. So it's okay. You can already trace back to that commit through some other path. So we're fine. By the way, before we do our merge thing, I want to show you something about these commits. No, actually, we have to do it after we do a merge thing. Never mind. So let's do it. What do we do to merge? Git merge. Git merge what?
You put the shell that you want to change.
Right. So that's part of the nuance of merge is where do you do it from and what do you tell it to do, right? So the way that Git handles it is you go to the place that you want the merge to end up in. So you're the final destination of the merge. So we want to merge to master. We go to master first and then merge other stuff onto where we are. That makes sense. So we want to merge this branch to merge onto master. So that means we need to make sure we're on master when we start. Exactly. So get there. We already are, which is nice. And then we say what it is we want to merge to where we are. Yeah. Let's see what happens. Okay, what happened?
Auto merging test, merge conflict, test message, merge automatic merge fail if it's conflict, and then it gives you 2 options.
I actually have like an editor.
It won't merge them because the changes aren't the same.
Test that sh when you open it, it gives you like
Did you get this also?
I got like head, current change, and merge to merge.
You might have, if you didn't change the first line in both branches, then it may just go ahead and merge it.
Okay, yeah.
Because you may not get a collision. Yeah, if you change the first line in both branches, then you'll get a collision. Unless you change it to the same thing. If you made the exact same change, then you might be okay. But I made different changes in each branch, right? So that's what it's complaining about. Now, this is the kind of the weirdness. It actually did change stuff, even though it failed. So if I do a git status, there's actually something, yeah, something has happened here. So if I were to, I don't know if I love this or not, but if I were to actually go and run my code, it would probably fail because now there's like stuff that Git has thrown into my source code that is completely not source code, right? It's a little ugly actually, but you know, that's what we sign on for when we do Git Merge. So let's go look at it and see what's in there. I'll just do it in code. So yeah, so you should probably see something like this, which is ugly but meaningful. So kind of step through what's happening. So the first thing you see is this is head, and all these you know, less than here mean that's the thing on the left side. Down to the equal sign is the change on or yeah, left side, my left. So that's the change here, and then below the equal sign down to the greater than is the change on the right side. And so what you have, you know, your mission that you have to accept is to sort all this out and figure out what you want to keep, and then take out all the you know, greater thans and the equals as well, because that's all just Git decoration to tell you where you're at. And then save it and add it and commit it right at that point. Once you get added, then Git knows that you've processed it, that you've done what needs to be done, and it no longer complains about it. But until you add it, it'll say that you have merge conflicts to resolve. So now, and it tells you, you know, where it's at in your repo. So what is head pointing to?
The master?
Yeah. In this case, we're on master, so head. It'd be nice if I told you that, but it doesn't. It just says head. So you'd have to say, oh yeah, that's master. So this is, you know, our comment gives us a hint too, but this is what we did on master, and this is what we did on branch to merge. So then we go through, maybe we want to keep them both. So we can do that. We can do whatever we want as long as we get rid of all this Git stuff, you know, and just leave our code. So that, you know, that's valid. Or we could say, you know, something else. Here is the sum of, or the integration of the changes I made on master and another branch, right? There may be code that you need to sort of refactor that accommodates whatever you did on both of those branches. So you can do that here. That's legit. You go back, see what state we're in. Still says both modified, right? Even though we do a git diff, you know, all the Git decorations don't show up because we fixed those. So now we still have to do a Git Add. Now it says we're okay, right? And then you can say something like, you know, my changes. And then if we look at the history, we should see something like that. So let me pause for 10, 15 minutes, give you a chance to you go through that yourself and take a break and come back about 25 after.
Oh, yeah. Yeah. Oh, yeah. I don't know how to. Oh, yeah. I would. Oh, yeah. Or John. loudly in it. Yeah, even in this room, even when you sit like outside.
Yeah, my last time the wall was so big in here. Maybe even when there's like no glass. I was like the wall. Like that's survival. CEO's office is one of like that. CEO that. Oh, someone's going to be off with it. Someone's going to be what? Then like they'll come out, but maybe so-and-so. Right. Yeah.